Hello everybody and welcome back to Groundhog Graphics live stream. I have been gone at work for several days and now I'm finally home to relax and enjoy some vintage retro programming. So the last time, I was thinking about it, the last time that I was live, I was working on a text scrolling routine for a windowed text scroller, vertical text scrolling, and I didn't get a chance to finish it, so I'm going to at least show you the finished product. So let's go ahead and get Vice opened up. I have several screens because I have this idea in my mind that I might try multitasking while doing things like compiling and stuff like that, so I'm not just sitting here. Might have been a good idea to do that before I even did video uploading on lives. I should have thought of that, but anywho, let's see. I have a lot of files on this disk, but the one I'm looking for right now is TX Scroll, and I'm going to give it a file name to open. So right now it's kind of like a file viewer, C64.h, and we can do the top row and the bottom row. And right now I'll just do full screen. But after this I'll run it again and show you can do a window. So right now it's going to load the file, and it's going to take the file contents and it's going to convert those from PETSCII to screen codes and then display it all on the screen. So there it is, it's converted. And I scroll down, go all the way to the bottom of the file. There it is. Scroll back up. It works pretty good. It's not bad. No assembly. Just doing this in regular straight power C. Now, if we escape out of this, go down to the bottom here, and I go to TX Scroll C64.h, and now let's say we go to top row for our window is 10, bottom row is 20. Now there should be a much smaller window that still scrolls our text. And you see, now we have a much smaller window. And the idea behind the window is for my application, my trucking application, is that I want to scroll questions on the screen, and I want to have a header and a footer on the screen. Like the footer would have menu options, and the header would be like, edit a trip or enter an expense, something like that. And I don't want those to change. I just want the questions to cycle through and scroll like this. So that's why I made the windowing scroll routine, and it works nicely. It's works really fast, and it works better than the first one I did. You guys didn't see that one, I don't think, but I did one in my trucking application, and it was kind of all over the place. It worked, and it worked well, but I didn't like the way it was just so incorporated into the code, and it made it feel like you didn't want to touch a piece of code because you're afraid you might break that when you're trying to implement something else. And that's why I made this so its own separate independent scrolling routine. That way you can edit your main code without feeling like you're going to break something else. So that's why I created this, just to really clean things up and make it easier to use it in another application. I mean, this is a pretty general purpose kind of thing. You might need this for lots of stuff. So I can take you on a tour of the code for it. Well, I guess I could have used the top space, but that's okay. CED TX Scroll. Let's see. source code. It uses a global, this is how I do my global variables, because in Power C, or probably a lot of old C's, if you have a global name for a variable for your particular little segment of your program, and then you go and you create your next segment or your main program, and you just so happen to use the same variable name, that it will cause the compiler to get confused. And when it gets confused, all kinds of crazy things happen, and you're sitting there going, what's going on? I don't understand. I had it happen to me once. And since then, I went ahead and started giving my globals, for one, a structure. That structure keeps everything under one name instead of all these variables just placed globally for everything to see. Because that would just, if I had 1, 2, 3, 4, 5 variables, that's 5 more chances of having a name conflict. But now I have only 1 chance of a name conflict. And so what I do is I tend to name it abbreviated from what the program name is, because we only have 7 characters to work with. TX scroll for TXSCR, text scroll, underscore C, and underscores, like, I use it for basically global things, special things. I don't like to use underscores generally, especially in function names. I'll give you that tip. Don't use underscores in function names, because if you create a library and you try to link your code, it won't see them. It has problems. As a matter of fact, if you're used to things like camel case, I tried that, and that doesn't work either. You need to stick with lowercase and no underscore, 7 characters. It's pretty limited for your naming. That's why I always come up with such fantastic names for my functions. So next, we come down the list and we have TX setup. And this is something, if you don't want this program to load the file for you, you can load up your own file and you can pass it to TX setup, and it will process it. It will set up your line is actually your buffer. Probably could have named it better, but line for lines. And this is how many rows of lines are in your buffer. And this is the top of your screen for the row and bottom row. So this limits your vertical size for how large your window will be. So then, after you run your TX setup, I have full instructions on this, and I believe I have them in the txscroll.h file, in the header file. I wrote up some stuff, just in case anybody wants to use this. But I figure if you're programming in Power C, you probably want to make your own stuff, kind of like I do. But it's there if you want to take a look at it. There's TX scroll. This actually does the scrolling. This accepts a direction, and you can do a direction of 1, 0, or -1, all of which have their own particular use. 1, I believe, will be scrolling your text vertically downward, and a -1 should be vertically upward. A 0, though, that won't scroll your text at all. But the interesting thing that I also added into this program was that anything that you placed on the screen, the minute that it scrolls, like if you print some text on the screen, okay, it will capture that, and it will place that text into your buffer. So that means you can literally use this to also take input. If you put a flashing cursor on the screen and the user types, my name is John. John, as soon as the screen scrolls, John is saved. But let's say when you're done taking input, and you don't want to risk the fact that the end user may not scroll up or down, you can send text scroll a value of 0, which won't scroll the screen, but it will save the current screen to the buffer. So That's why it has a 0 in it. It uses bcopy, which is a function that's included in PowerC, and that's what makes it so fast. I was trying to run it with a loop before, and it worked, but it was a little jerky. It wasn't smooth. The bcopy made it real smooth. So that's our scrolling routine. Not much to it. This will clear the window. So this clears the viewable window with spaces, because the space in ASCII is 32, and the screen code for space is also 32. Now, oh, that's another thing I'm doing too, while I'm looking at it. The global variables, like I said, tx_scr_c, when you want to use those in a function, it's not convenient to type the underscore and all that. So instead, I've made a type def for tx. I create a temporary pointer. I point it to my global structure, and I just name it G. And then I can access all the elements of that structure with the G dash whatever for that element. And that's what I do just to kind of make it easier for typing. And we have tx fresh for refresh. And really, it's not really necessarily a refresh. It's actually the first function you have to call. After you've done your setup, it's the first function you call before you try to scroll the screen. If you try to scroll the screen without calling this, it'll take whatever's on the screen and it'll save it to your buffer and overwrite whatever's in there, and obviously would cause you problems. It wouldn't work out right. So tx fresh is first, displays the initial contents on the screen that you want. Then you can call tx scroll after that. Tx load handles the loading process. So if you have a text file, it expects a text file to be limited to 40 characters wide. So if you use the editor here to create like a set of questions, and your questions stay within the 40 columns, it'll load it up fine. If your questions extend out, because this can go, PowerC can go to the right, like that. You do that, it'll probably be, I think it'll be cut off. I think that's what'll happen, but I'm not sure. I didn't need to try that. But basically, when you set up your questions, make sure to keep it within 40. And then txload loads it, so that's your file name. Once again, L is your buffer. L size is the size of your buffer in bytes, and the top and bottom of the screen, your top row and your bottom row. So then it will load it up, and I think, will it load it? I think you still have to display it manually. Yeah. It doesn't display anything. You still have to call tx fresh with no parameters, I believe, and then the tx scroll, and then it will work as expected. Tx close is important, and this is untested. I haven't even tested this, so it may cause trouble. Tx close takes the screen codes and converts those back to PETSCII, so that way you can go ahead and take whatever happened when you're done with your window, take whatever input you got, and it's back to PETSCII, and you can do whatever normally you could do with it. And I do have a function that will terminate all the rows by skipping spaces, and that would also happen if when a tx close is called, but I know there's a problem in it, and it's not exactly something I can easily fix. But basically, if you have text that extends all the way to 40 columns, then it will place a new line character, or actually whatever terminating character you really want. That particular function has that ability. But this one right here, it'll place a new line character, as you see right here, screen to string, after that column 40, which would actually end up putting the Terminator over whatever text is on the following row at the very first character. So that wouldn't work out. So if your answers go to the last, column 39, that would be a problem. There is a way to call, not TX close, but a way to convert the screen to a string and not have it add terminators, and then you could just do it yourself. But it would still convert the screen codes to Petsky. I think that's going to be in another file, but let's get through this one. So TX close, very important. Call that before you're done with everything. Otherwise, your file that you loaded, it'll leave it a mess, and it will be in screen codes, and it won't be in the Petsky that you expect. And then we have a main function for debugging, and that's just what you saw for the file viewer. And just up and down file viewer. And that's the text scroller. Now, what was it? Oh, string screen, I think. Let me see here. Go. One. Get str to, or scr to string.c, or is it the other way? We'll see. Okay. Get str to scr.c. String term right here. So what this does is it goes through after your file's been converted from from screen codes to Petsky. Then this program goes through, checks for spaces and characters, and any space it skips over, and the very last character per row it places that null terminator. The terminator can be set manually with the T character, so you can set it to be anything you want. It could be a 0, it could be any character. So typically a 0 or a /n or a like a carriage return 13, ASCII code 13 for that. But then if you were to call this a second time, you could actually add an extra terminator. So every time you call it, it would actually, you could add a /n carriage return, call it again, and add a 0 at the end of that too. So that's kind of neat. And then we have the string to screen, and that right here just converts it. And the source, destination, length. Oh, this does, I think, per row. What is this? This looks like I have a conflict here. Oh no, screen to string. I was like, wait a minute, probably the same name. So screen to string. So string to screen converts Petsky to screen codes. This one does vice versa. So screen to screen, screen to string does a string width. So like 40 columns, your terminating character. And this is, I think, the length in bytes, the source and destination. So source of what you want to convert, the destination place of where you want to convert it to, which can be the same as source, the length in bytes of your buffer, the width of your lines, which would be typically 40, and the terminating character you wish to use to end those lines with. And that's it. There it is. So there's the text scroller. Finished. And I can use that, but I've been working on relative files and trying to get around the fact that they're 254 byte limits. The maximum size of a record for a relative file is 254 bytes, and I need like 550 bytes, And if you wanted to save a screen, you'd need like 1,000 bytes. So I've been working on a set of functions to get around that 254 limit. And that I'm still working on. Almost there with it, but I have a bug that's continuing to cause me issues. So that's where I'm going to go at this point and try to find that bug, which is going to take probably a lot of compilations and trying to sort it. And while it compiles, I am going to probably be working on updating my copy program that I made a while back. It's not really finished. Well, it's not polished. It's not perfect. It's not very good even. It needs some work. So I need to go through and I want to kind of add some features to it. So I might do that in between working on my relative file bug. So quit, and we will do rand f. So rand f is for random file. And this is my executable that I have so far, which does not work. These are the options that you can do for the debugging, testing. If I can use this randf29 to create a test file. That seems to work okay. And then I can go to save the screen, and this one right here, this one seems to not work okay. That's some debugging information I've put in there. I can see it's going through everything, but it doesn't seem to be saving anything. And then for my last option, which is 4.9, this is supposed to bring up our previous screen, load it from our record. And you can see that it will not do that. Now first it tells you the record size is 1,000, so it saves the fact that it knows it has a record size of 1,000. But it won't bring in the screen up. Buffer shows correct. Everything seems to show correct, except I thought I had a position on here. I don't. So I need to take a look at that and see what position is saying. It says the buffer is 1024. It should be loading whatever is in the file to the screen, but nothing clearly comes on the screen. Nothing. Nothing at all. And even when I check the file, ed random file randf.ran, I see no text. I don't see anything saved in it that indicates that it even saved anything from the screen. These look like character 255. It looks empty. Which is odd. I don't understand, because, you know, it's funny. I save a block allocation map, and I save the record size in the very first record, and that seems to save. But this doesn't work, so I'm going to quit this, go to the syntax checking editor, and I'm going to take a look and see what I can figure out here. randf.c. And if you guys join my live right now, I can't see it. I've got full screen here for Vice. So if you comment, I'm not ignoring you. I can't see it. For one, I need to update that today. Well, Groundhog Graphics, I kind of wish that I just not kept the lowercase g at the end. I should have just made the G for the end of the Groundhog and for the graphics. I mean, that's like how many years too late, but that's what I'm thinking these days. I should have just had the 1G. That would have been cool. Just think that. Whatever. It is what it is. See how I've done my global? This one's for rand f_c. And then I have a type def global for RF random file. Keep those globals from getting mixed up with other stuff. And then make access easier like this with a pointer. RF close is very important in this because it will save your BAM that's been updated. If you've written anything to your file, your random file, it will save the BAM, which is going to be pretty critical for you to be able to access the data again. New works. And here's my problem child. So let me look at this because this works up here. F right, G buff, 1, 254 FP. G buff works. And this prints here, P. This F print positions the relative file to be on the correct record. And for the BAM and for the record size, it's going to be record 0, and that saves, and position 0. So you have the what is it, the lower byte, the little endian first of your byte of your word, and then you have the upper higher byte, and then you have your position, which is character. All of these are characters, of course, because that's all it can accept. So that's why you have the low and high byte right here of your record number, because your record numbers can go up to 700 and something. It's in the book. It's like 710 something something. It's in the book on the 1541. I think it's the user's manual you get. That's pretty comprehensive. It has a lot of information in it. It's pretty good. It has some errors in it too, though. I remember that from the past. So you've got to watch it. A few errors. Alright, so that writes normally, and this doesn't. And why it doesn't, I don't know. B is the buffer, run with FP. No, that should work. Make my screen a little smaller. Let me open it up. Oh, that's right, because I'm recording my desktop this time. That way if I switch screens, it's just easier. Because I try to do scene selection, and the thing is, it just was difficult. It was easier to just do the whole screen. So, doc, let's see. Stats. Oh. Okay. Sources, chat. Okay. Let's see if this chat connects so I can see if somebody joins up. Okay, I'll be right there. Be right back. All right. Let's see here. Sorry about that. Had to get the cherries. Okay. Now, back to this. Record number, buffer requisition. It's all in order. And it goes to position the relative file pointer. Oh, that's right.